Okay, so the balloon is rolled up and it cannot touch the ground. So we unroll the balloon while people are holding it.
Okay.
This is obviously just an example.
Yes.
It's not a real balloon.
Dry run number 1. Okay, now we take the fill hose for the helium, insert it into the neck of the balloon.
Then you loosely attach a zip tie to hold the filler tube in the balloon while it's filling.
Okay. Now we open the helium bottle and start filling the balloon. And then the balloon starts going up.
Yeah. It was recovered on December 7th in Windham, Maine, and this is the footage of unsealing it. What you just saw is one of the signs that was taped on the hab so that anyone who finds it can identify it as a university research experiment. It's in big letters because we kind of anticipated that there was a high probability of it landing in a tree. We taped similar signs on all sides so that it is visible regardless of the angle it lands on. We sealed the payload with packing tape and Gorilla Tape on the day of launch to try and help with waterproofing the signs as well as our internal components. The parachute is required by the FAA for any high-altitude balloon launches. To tie on the parachute, we drilled 4 holes in each corner of the hab. Plastic straws were inserted and then a metal washer was hot glued around the outside for stability. The straws and washer are used to prevent the parachute cord from ripping through the styrofoam during setup, liftoff, and descent. Hot glue was applied liberally to mitigate any chance the washer and straw have on damaging the parachute cord. However, this does make disassembly quite a lengthy process. We had a silver radar reflector that hung beneath the hab, but it was unfortunately unrecovered. The radar reflector was built out of cardboard cereal boxes and then wrapped in aluminum foil so that it can be picked up by planes and recovery teams. Our payload itself contained 8 subsystems. Number 1 is an MSP430, which is a microcontroller made by Texas Instruments. Here we have programmed it to read temperature and pressure sensors and then log the data on a microSD card. 2 is a GPS module custom built by one of our members. 3 is another MSP430, which is blinking the LEDs in Morse code to say, "Hello from RIT." 4 is a custom board dedicated to the power distribution. 5 is our recovery assistant board, which is in charge of running a buzzer located on top of the payload, as well as the LEDs. While the LEDs and buzzer both ran out of battery life long before our payload was recovered, it was designed to assist in the process. 6 is the Automatic Packet Reporting System, or APRS module, which allowed us to specifically track the location and altitude of our flight wherever there were stations picking up our call sign. 7 is our GoPro module, which had a hand warmer squeezed behind it during launch. The wooden piece on the side of it is actually a chopstick. It fit perfectly through the GoPro casing and kept it sturdily in position. The camera was set to take a photograph every 10 seconds. 8 is the power supply, which was wrapped so tightly in insulation that you can't really see it. It's made up of 8 rechargeable 18650 lithium-ion batteries, and 3 hand warmers were packed in to help with the battery life. Thanks for watching our first RIT SPEX high-altitude balloon launch. We look forward to having many more in the future.